We're ready to develop a really important formula that you're going to use in several of the classes that you take in the future. This idea is not going to go away. It's going to continue to come up, and you'll probably be asked in several classes in the future if you have this memorized. So if you get this figured out now and get it memorized, then you'll be in pretty darn good shape. So this is part 2 of this section in 8.4. The I can statement is I can find the distance between 2 points using the distance formula. And this is what we're going to come up with today. We're going to come up with something called the distance formula. Now, yesterday when we were doing this assignment, what we did is we found the distance between 2 points by drawing a triangle and then using the Pythagorean theorem. We're going to do the same thing today, only we're not going to be using a graph as much. I'm going to start off on a graph and then we'll kind of wean ourselves off that. And here's the reason. Graphing is not very accurate. Graphing is not very accurate. If you're going to find the distance between 2 points using graphing, you've got to have a piece of graph paper, you've got to graph them accurately, and you've got to be really, really careful. And if you're not really careful, then you're going to get the wrong answer. If you happen to count the boxes wrong, if you happen to graph them wrong or something like that, you're going to get the wrong answer. So we can use the same ideas as what we used yesterday and come up with a formula that gives us the right answer every single time. And here's how it's going to work. We're going to start with 2 points. We're going to call this one x1, y1 and this one x2, y2. And we're going to use d for the distance between them. Should sound kind of familiar. So here's what we're going to do. We're going to put a point right here and we're going to call this point x1, comma, y1. So I'll put that in parentheses. And then I'm going to come up here and I'm going to put another point and we're going to call this one x2, y2. Okay? Now, I'm going to draw a line between the two of those and we're going to call this d. That is going to be the distance between the two of those. Now, if I draw a right triangle between these, like I did yesterday, I'm going to do it in a dotted fashion right here, and I'm going to put an angle between the two of those. So there's our right angle. Okay, I'm going to take this point and I'm going to follow this around and I'm going to mark these off. So the x coordinate, if I follow this down here, I'm going to put a mark right here. This is point x1. And if I wanted to know where this point was, this would be the x coordinate up here, so this would be x2. So for this first point right here, if I mark this on the x-axis, this is x1, that's the end of this line right here, and the other end of this line is at x2. Those are at least the x coordinates. So we're just kind of breaking this down horizontally. So it starts at x1 and it ends at x2. Now in the vertical direction it does something similar. So this one over here would be y1, and if we follow this one, this would be y2. Now the reason it's important to know what these are in terms of their subscripts and things like that is because we're going to develop a formula that we can just plug in the points and it's going to spit out the answer. So if you remember what we did before with this when we were developing the slope formula is we did this. If we want to know how far it is from here to here, we're going to do the one on the right minus the one on the left. So we're going to do x2 minus x1. If you always do the one on the right minus the one on the left, that's always going to give you a positive quantity. Okay? Now, if we set this one up the same type of way, if we do the top one minus the bottom one, we could get an expression that represents how far it is from here straight down to here. So if we started off here at y2 and went all the way down here, y2 minus y1 is going to give us an expression for how far that is. So if you'll notice what we have now, we have the distance from here to here. This is a leg. So the leg that goes from this point over to the right angle vertex is x2 minus x1. And the distance from the right angle vertex up to this point right here is y2 minus y1. So we've broken this down into a horizontal movement and a vertical movement, kind of a run and a rise if you want to think of it that way. So here are the two legs and this right here is the hypotenuse. So I'm going to write that down here. This is a leg. This is a leg, and this right here is the hypotenuse. So here's how we're going to do this, and this is why it's important that you did this yesterday in the order that I asked you to. So we're going to say that the distance between the two of them squared, so the hypotenuse squared is a leg squared, so this is going to be x2 minus x1 quantity squared, plus the other leg squared, and the other leg squared is y2 minus y1 quantity squared. So again, notice what we've got here. We've got leg squared plus leg squared equals hypotenuse squared. So the distance between the two of them squared equals this leg squared, that horizontal distance squared, plus this leg squared, that vertical distance squared, and we're all set to go. Except for we don't want to know what the distance squared is. We want to know what d is. We want to know what the distance is. We want to get this by itself. So if you notice down here, we've kind of got a big hint here. We've got this big radical. Well, if we don't want the distance squared, if we just want the plain old distance, then here's what we're going to do. We're going to take the square root of this side, and we're going to take the square root of this side. Now remember what happens here. The square root will undo the squaring. So we end up with this. We end up with just a plain old d. If you wanted to think of it this way, there are a pair of d's on the inside, take one on the outside. Okay, that's how those operations undo each other. And then here, this is our distance formula. So this is the way I like to say this. So we're going to go ahead and write this down. So this is going to be d equals, we've got a square root here, and then it's going to be x2 minus x1 quantity squared plus y2 minus y1 quantity squared. All right, so there's the distance formula, and this is the way I teach it and the way I remember it. So if somebody says, what's the distance formula? You say this. You say d equals big square root. So it's a big square root, big long square root that we had sitting there at the bottom of the page for a minute. Big square root of x2 minus x1 quantity squared. Now, you may have heard this before, but when somebody says quantity squared, what they mean is put that stuff that they mentioned previously in parentheses. So that means put parentheses around x2 minus x1 plus y2 minus y1 quantity squared. So let's spell quantity right here, quantity squared. So again, this is the formula. If you're a good visual learner and you can just remember what the formula is, you do have to have this memorized. But if you're kind of a auditory learner, or you learn better with words than with pictures or with symbols, you might want to think this. The distance formula is d equals big square root. So we do this big giant square root, x2 minus x1 quantity squared, so we put that in parentheses and we square it, plus y2 minus y1 quantity squared. So that's what it looks like, and that's the formula that we're going to use. Now the cool thing about this is this doesn't require us to graph anything. We literally just plug the points in, the coordinates of x and coordinates of y for each one of the points, plug it in, be careful as we go through and simplify, and we're all set to go. So again, I'm going to write this down. We're going to say d equals big square root x2 minus x1 quantity squared plus y2 minus y1 quantity squared, and then we just simplify. So this is going to be x1 y1, this is going to be x2 y2, and then we'll take these points and we'll plug them in. So that means our x2 is going to be right here. So this is going to be a 4. So I'm going to write d. And again, you're not going to have to write this every single time. So I'm just going to write the big square root, the parentheses, and this is going to be 4. Write the minus, then go find what x1 equals. Minus 5 quantity squared plus y2 is 0. Write the minus, and then go find what y1 equals, quantity squared. So this is going to be 4 minus minus 5, so that's going to be a plus 5. So this would be a big square root, and actually you can do this. This is going to be 9 squared. Not a bad idea to keep that in parentheses. This is going to be negative 3 squared. So we've got a 9 squared right here, which I'm hoping that we know. This is a negative 3 squared, and just a quick word, remember when you square a negative, this means negative 3 times negative 3. So we've got 2 negatives and 2 3s, so it's going to end up being positive. So this is 81, and then this is 9. So d equals square root of, add those together, square root of 90. Now, this is really close to the correct answer, but we're not quite there. Remember, we want to write this in exact form. So let's break this down. 90 would be a 2 times a 45, which would be a 9 times a 5, which would be a 3 times a 3. So the square root of 90, oops, let me write this out, 2 times 3 times 3 times 5. So pair of 3's, so 3 on the outside and a 2 and a 5 stuck on the inside because there's nothing to pair it up with, and we'd have 3 radical 10. Okay, so there's the answer. If you wanted to get a decimal approximation for that, that would be fine, but I do want you to have that in exact form, so make sure you practice that. So I'm going to draw a little line right here, and we're going to switch colors, and we're going to come over here. I do want you to take a look at this one. Notice how many negatives there are. So remember, this is going to be d equals a big square root. Okay, and we're going to be adding together two squared quantities. And remember, it's going to be a subtraction problem in both of those. If you'd like to set it up this way and then plug in the numbers, that would be totally okay. For some people, that works well. So I'm going to write x1, y1 here, and this is going to be x2, y2 here. So this is going to be x2, negative 1. There's the minus. x1 is negative 3. Then it's going to be y2, negative 4, minus y1 is negative 1. So for the time being, I like to write this, and then I drop this big radical off for 1 second. This is going to be a plus, so this is going to be 2 squared. I do keep the parentheses on there. That's a really good habit to be in. That'll save you quite often. This is going to be a plus, so this is going to be a negative 3, and we're going to square that. 2 squared is 4. Negative 3 squared, again, whenever you do this, we end up with a positive, so this is going to be a plus 9. So this is going to be d equals the square root of 13. Now remember, 13 is a prime number. We can't break that down. We don't have any pairs of factors, so we would be done right there. Again, if you wanted to get a decimal approximation for this or a decimal approximation for this, you're welcome to do that to get some sense of how big the number is. But we've estimated these types of numbers before, and the instructions say get the exact answer, so definitely do that. Okay, let's take a look at the next one, C. We've got some points here. Again, I'm going to write down a D. I'm going to write a big square root. If this is helpful, rather than writing the whole thing down at once with the numbers in it and with the pluses and minuses and all that sort of stuff, go right ahead. We're going to put a minus in the middle here and a minus in the middle here, and then we're going to go find the numbers that we need. So remember, here's our x1, y1, and I'm going to write this down several times just to make sure we're all clear what we're grabbing. So this is going to be x2, which is a 6, minus x1, which is a negative 1. This is going to be y2, which is a 6, minus x1, which is a negative 1. This doesn't happen very often, but you'll notice the x's and y's are the same here, and the x's and y's are the same here. So here's what we'd have. This would be a plus, so that would be 7 squared. This would be a plus, so that would be 7 squared. So we're going to have 49 plus 49. So this is going to be d equals the square root of 49 plus 49 is 98. Now, if you're responsible for simplifying this, here's what you'd have to do. You'd have to break this down, but we've actually got some help here. Remember, this is two 49s added together. So 2 goes in here 49 times, and 7 goes into 49 7 times. 49 is 7 times 7. So I'm going to write this out. We've got a 7, and a 2. Pair of 7s, that's on the outside. 2 stuck on the inside. And there we go. Okay? All right, one last problem. Let's take a look at this one. We're going to write d equals big square root. Again, for some people this is really helpful to write down the formula and then go plug in the numbers. Remember that minus is part of the formula. If we slide back up here, there is a minus in the formula. So don't get messed up when there's a negative number. Don't think that was the minus that was already in there or the negative that was already in there. It's not. So this is going to be x1, y1. This is x2, y2. We'll plug those in. So this is going to be 8 minus 8. All right, we can deal with that. That looks a little weird, but we can deal with that. And then this one, y2 is 10 minus 1. Okay, so this is going to be 8 minus 8. That's going to be 0 squared. Again, leave those parentheses there. This is going to be a big plus, so this is going to be 11 squared. So this is going to be d equals, this would be a big square root of, this is 0, and this is 121. So this is the square root of 121, and we end up with 11. So 11 would be the answer there. Now, unlike these three problems here, the other colors, this one's, the black one right here, worked out to be a nice number. Worked out to be exactly 11, so a nice positive integer there. Now, the reason for that, notice that this one turned into a 0, is this. This point is 8, negative 1, so we'd go over here and down to negative 1. This one, we'd go over 8 and up to 10. So what happened here is the distance is actually just a vertical line, and since they both have the same x-coordinate, this is from negative 1 up to 10, and we could count that. This is 1, and then 10 units up to there, we'd get 11. So unbelievably important that you understand how to use the distance formula, get the answers in simplified radical form, be able to throw them in your calculator if you needed to, especially if it was a story problem. But this distance formula is extra important. So please make sure you have this memorized. Be able to write down what the formula is, or be able to say what it is in your mind and then write this down here so you've got the formula memorized. All right, that's similar to the problems on the assignment. Good luck.